Well, that sucked. Let's try this again. Try this again. So yeah, we did get some melting. It's not, this is what I was trying to show. It's not super brittle. Focus. And I'd be able to show it, huh? No, I'm not showing it very well. Well, I'll get pictures of it too, but it'd be wonderful if it would show up. Maybe this one works better. Because of the backlight, you can see there's there's two spheres on either side. Two little spheres that formed on either side. Make that for what you will. Sure. Certain people will enjoy that. I'll take better pictures of it. Pretty interesting. Alright, so let's take a look at the quartz tube now. So yeah, there is some melting once again on the quartz tube. I mean, for an 8-hour run, that's not too bad. You can see like fractal patterns where it just got very, very hot. We'll see if we can pick this up. I'll try it on here first. Wipe off any. Not sure if we can pick it up very well. You can kind of see it there. Maybe if I use some light. Okay. If I turn this off, it might be helpful. I'm not using it anymore. We'll see here. Focus. Yeah, I'm not sure if you can see it very well. I think my computer webcam might be a lot better than this fancy one I bought, which is sad. So we'll go to this one. Let's see. So what a glare. I don't know if you can see that very well, but there's some deformation. It looks like just looks like fractal patterns basically. Little fractal patterns. And it's on one side, probably because the electrode when it sits in here. Well, two reasons actually. Now I'm looking at it. But when it sits in here, it kind of leans. Yeah, so you can see it. It leans to one side. more than the other. Fall out if I don't hold it though. And yeah, I'm not sure you can really pick that up very well on either camera, unfortunately. So still getting a little bit of quartz tube destruction. Pure alumina tube I won't be able to see through anymore though, so I'll have to rely on sensors to pick up when there's ignition, which isn't too hard, and also, you know, sound too. But so now grab the palladium. So this was an old quartz tube I used, so it already has a spot where it was melted by a wire a while back. But it's looking like this palladium, I'm gonna have to get a new platinum. I'll have to get a new platinum anode because this thing is like, it's browning. I've used it a lot. Probably should retire it. Yeah, I'm trying, Mescal. Tried, man. It's just, it's hard to get a shot of it. Try again, man. I'll take pictures of it and put it in the Discord. I know you're in the Discord, so you'll see it. But maybe I can get it like this. I can get it where it's not shining on it too much, but rather through it. Let's see. There, you can kind of see it. See that? And it's just on one side. The other side's not so much like that. And obviously on the bottom, that's just where I cut it. I did the trick that you mentioned with the paper towels and everything, but I think I have a cheap tile saw cutter, so you can kind of see it there. See right there? So still, it's getting pretty hot in there still, you know, obviously. And I didn't show you this, or you came in late. Probably see it better on this camera. Made two little balls. See that? One bigger, one smaller. And I'm sure Bob's gonna love that. I don't know what to make of it. I mean, it is interesting, but if an arc is occurring across it, it would build up on two spots, and then it's kind of hollow in the inside a little bit. But I pushed it really hard because I really wanted to test it to see how it would do. I'll probably just mechanically clip these off and just put it in a test file to be tested someday. But the ceramic held up nicely. The ceramic, the alumina standoffs held up nicely, and the 3D print held up pretty well too. This is the PTG, so it's supposed to be highly chemically resistant. Yeah, I figured you'd like that. See little spheres. I'm just gonna go full screen on this one because the other one's not so good. My other camera is supposed to be a lot better. Go full screen on this one. And put it down a bit. There we go. So that's nice. The PT, or the platinum, I'm gonna have to buy a new one of these. They're not too expensive. I think they're only like $30. I'll have to get another one. It's like a jeweler's platinum coated titanium mesh for jewelry. So there's that. Now I have another problem, which is I think it got kind of hot on the bottom, and there's a magnet under here. Oh, well, maybe it'll come up, and hopefully it's just the tape got hot and the adhesive came out and stuck to the bottom. I really don't want to force it though. Feels like it might be just the tape. I hope. But before I do that, I think I'll pour it out just to be safe. And yeah, I think it's just a tape, but you can definitely see. I'll put this up over here. You can definitely see where the magnet picked up carbon popping off of it. Or nickel, I mean, nickel popping off of it. Yeah, just a tape. That's good. An angle of it. Yep. Little nickel pieces. Oh, and some quartz in there too, it looks like. That's when you know you're pushing it too hard, when you break off nickel pieces. Can't really see it. Let's try this other camera. This other camera's supposed to be better. See it in there? Yeah, I'm not sure. I mean, it should just be. I mean, quartz melts at I think 1100 degrees Celsius. I believe it's around 1100, 1200 degrees Celsius. So hydrogen also burns around that temperature. So, you know, the jury's still out on that one. It is definitely deforming it, which isn't good. So it means I won't be able to see reactions moving forward if I'm gonna try to build a cavitating tube properly. It'll have to be made out of ceramic, like a alumina. So verdict's still out on that. I don't want to jump. You know me, man. I don't want to jump to conclusions. I'm just testing it out and trying to eliminate all possibilities. So, put definitely, if I get it going correctly, it definitely creates a tremendous amount of heat and light for very little power input. You know, still just gotta work on saving up enough money for the flow calorimetry. I think I'm gonna sell some Bitcoin and purchase it, because this this style of flow meter, it doesn't work very well. It's kind of hit or miss. It might have to do with my coding abilities too, suck, but yeah, it'll have a floating point, it'll go negative, and looking at the spec sheet of it, it's like a 10% margin of error, which is really freaking high. I mean, hopefully reactions I would see more than that, you know, but you gotta, I want to eliminate the noise to signal ratio, you know what I mean? So. But yeah, that's pretty much it. I'm just going to clean this up. Just wanted to do a post-mortem. I just ran it briefly again, and I'm not sure if it's building up like an oxide layer, and it makes it also challenging to get ignition on. But I do know that this cell, or the tube, builds up a tremendous amount of pressure really quickly, and that's probably more likely. Is it just, you know, it just pushes all the solution out of the tube, right? And so it hovers right around this lower region because there's no pressure relief up on the top part. And in the past, I would use basically like a diaphragm. You know, I used a PTFE diaphragm to make that like a pulse jet type of thing, you know, make that oscillating thermoacoustic oscillator, right? And with the way that this one's set up, you can see there's no relief there. So, oh man, it's on super tight. You can see that better, probably. See in there, just, and looks like it melted a little bit in there too. Yeah. So I did melt the top of this a bit. Actually, looking at it now, yeah, this whole top piece is fused onto this. That's interesting. So now this is a permanent fixture. You can take this out. I guess I should be able to. There we go. Yep. Melted in there. Yeah, I can't break it free at all. Alright, well that's interesting. That's not too big of a deal, as long as it's not dripping into the cell. I was pushing it pretty hard though. The protons are so small it fits inside the crystal lattice of the quartz, loading it up. Then the energy pushes more protons, flaking it off, revealing the crystal structure, hence the fractal pattern. Yeah, possibly. I mean, there's no so I don't know. Yeah, I mean, if it's a barrier between the anode and cathode, right? I could see how the plasma would want to, try to channel through. And on the last the last quartz I actually had patterns on the outside as well. I sent those off to hopefully get analyzed, but I haven't heard anything from it yet, which is fine. But this one, however, is just all on the inside, so it's just all on the cathode side. But that was just with a wire. It wasn't with such a thick cathode like this one. So yeah, it's a good hypothesis. I'm not sure how we would test that without, you know, I mean, obviously do spectral lines and stuff like that in the process, in the actual reaction process, and you know, just better, more detailed spectral analysis would be wonderful, but that shit costs a lot of money, so kind of matter of resourcefulness, having a lack of resources. But anyways, that's pretty much it. I just want to do a post-mortem. I did another quick run. I don't know if you saw the last videos, Mescal, but the I was getting slow oscillations because of what I was saying, because there's no relief on the top. But when I was getting oscillations, I tried using this analog. I didn't try using it. I did use it. This analog tri-field meter, and I was getting some very large electromagnetic field radiations. And what was odd is even when I wasn't getting plasma, there was still quite a prominent field. So that was kind of interesting. What else did I learn besides what I can do better next time? Yeah, you have to see the video. Obviously, like I've been talking about for a couple of years now, is that calorimetry. It's really what I need to focus on before I feel comfortable enough, like shouting from the rooftops to people like this is legit. Even though there's lots of papers, like both you and I know, that say that there's a lot happening here, and there's certainly phenomenon that happens, and I feel like I've witnessed it with some of the experiments I've done, but just how rapidly it would boil water at such low input energy. But that's kind of anecdotal. I need hard evidence to be able to, you know, send someone a CSV file with footage that's all time stamped, or they can even look on YouTube, and then I'd be more comfortable with saying, hey, this is for certain, there's something going on here. So that's the whole aim of this project, always has been. Anyways, thanks for watching, brother. I know not a lot of people are interested in this, so the few that are, I appreciate. But